All right, so I think we can get started, and if others join in the meantime, that's fine. So yeah, welcome everyone to Sail. Here's Karen. Hi, Karen. Welcome everyone to Stateless Implementers call number 49. The agenda has been shared in the chat. We have 3 points today. So yeah, without further ado, let's get started. Starting with team updates. Maybe Guillaume, you want to lead this?
Sure. Yeah. So personally, doing a lot of work with binary trees. Found a few issues, including an endianness problem that's going to be discussed during this call, and also performance issues. So in the initial implementation is currently in guest master. We were okay. That wasn't in guest master until last week. We were recomputing the entire tree all the time, so that was a huge performance hit. So that has been corrected. Otherwise, there's been some back and forth with the team, but I guess Han will talk about this, about changing the structure of the tree. Yeah, still open, but we're going to talk about this. Or actually, was it the other thing, Han? I forgot. Which one are you going to present?
Okay. Trying to present the new one, but I guess maybe if we have time, then we can go through the binary tree changes as well. Because it's quite early, it's a draft, but I guess we can share it right now. Yeah.
Right. Yeah. Sure. Yeah. Let's do that if there's time. So yeah, those were the three main things. I'm sure there was a billion things on the site as well, but that was the main focus.
On Bezu side, but not a lot on our side. We had some talk with Guillaume because we tried to have the same state route between Get and Bezu, but as Guillaume said, he found some issue in the implementation. So I think we'll have also to do some fix on our side. As he said, also we'll talk about what he found, and we should try to update the binary tree implementation in Bezu because the main branch moved a lot. So I have to book some days, maybe this week, to update the implementation. And yeah, it was mainly that on Bezu side, not a lot.
Thanks. Anyone else? Maybe Milos or Thomas or Han. All right, sounds like we're done for team updates, unless someone manifests. This brings us already to point number 2, which was a point from Han. It's about activeness-based state access repricing. So Han, if you like, you can take it on from here.
Sorry. Can we move on to the next agenda item first? Because Maria just texted me that she wanted to join the meeting. So let me just send her the link. Yeah.
Sure. Yeah. Then we can go ahead to point number 3 from Guillaume. I know, Guillaume, you were kind of preparing the slides. Are you ready to present already?
Yeah, believe it or not, I was getting ready. I just need another minute, sorry, to set up, but that will be quite fast, I hope. Yeah, here we go. Okay, so now screen sharing. Okay. Yeah, so what I want to talk about is some tweak, something that came up during the debugging session that I had in the previous weeks, and the reasoning is that if you look at the EIP 7864, which is tree embedding, you have the way you compute the key, get tree key. I hope people can read, otherwise let me know. I will increase the font size. So you get the address, and then you get the tree index, which is specified in Python, which is bigint, right? And then the subindex, which is not really interesting to the current conversation. And then out of this comes the hashing, right? Where you first hash the address, which, by the way, is a 32-byte number. And then you also hash the tree index, which is also a 32-byte number. And it's serialized in Little Endian. And then you take the hash, you take the 31st bytes of that, and you add the suffix. I mean, that should be obvious to everybody who has implemented the code, but yeah, bear with me. I just wanted to recap because it's going to be important. So if I look at the way this works in practice, I have, right, so yeah, that's going to be a drawing. I have the address, right? I have what's called the offset. And the offset is split into two. This is known as the tree index, and this is the suffix. All right. And what you do, okay, so one important thing, I'm going to represent the endianness starting from the most significant byte to the least significant byte. This is a 20-byte big Endian address. This is a, so I'm only talking about this. This is a 32-byte big Endian. This is just 1 byte, so the endianness doesn't really matter. And then what you do is you're going to take a hash of 0 to make the address a 32-byte a 32-byte number. So it's still big Endian. I mean, it's 0, it doesn't matter, but the address as a whole is red big Endian. So it's 12 bytes. And then you have another number, which is just this copied over. So it's big Endian 20 bytes. And then this is a 32-byte number. So right, the offset, right, was a 33-byte big Endian number. And I can explain, if it's not clear, why it's a big Endian. Sorry, what's 33 bytes? It's because if you look at the way it's implemented, it's specified in the spec. The offset for a storage number adds the value, like take the storage key, which is the slot number, and it adds main storage offset. And if you go to the definition of main storage offset, this is a weird way to write a number which is still which is 2 to the power of 248. So it's actually a 32-byte number with just one bit set in the most significant byte. So if you add two 32-byte numbers, one of them, like if the top of the, so you have the slot number, and if that value is 255, if you add another number which is effectively 0 and here it's 1, this together could overflow into a 33-bit number. So this is 32, this is 32, and this is 33. And then you chop off, so this is the same thing as that. And if you chop off the last byte, you get a 32-bit number again. 32-byte number again. So this is copied over here. But as I pointed out, if you look at this definition, it's Little Endian, which means that this thing is actually a Little Endian 32-byte number. of which you take 31, and then you add that suffix. So what I would like to do, because you have this conversion, like this, you have this number, and this is a another number. So it's the same number in a different representation. But what's a bit silly is that, well, okay, this doesn't really matter, but this is big Indian, this is little India, and the final result is taken as a big Indian number again. So what I'm suggesting is that we replace this with basically what I'm suggesting is that what we do is, let me just copy, we change the method to do that instead of what I just did, which is we remove this part and we just say it's going to be a 32-byte number but big India. So I just want to change the spec to use the NDNS, the initial NDNS. Why? Because then we don't have to do a flip. In terms of performance, it doesn't really change much because you're going to have to copy that data anyway. Yeah, you need to copy that data from the slot number into the hash buffer. So it's not a performance issue, but it's a readability issue, simply because you don't have to do the big Indian conversion. It's just a simple copy. And yeah, just having two different types of NDNS inside the same part of the code is going to cause a lot of issues. And in fact, it did, because what I was doing until now, and it's also probably wrong in Besu, but I assume Thomas or Karen can confirm, what was being done until now in the guest branch was still having 0 here, having 20, sorry, not here, 20 bytes here, and then this was 31 bytes big Indian, and then a 0. So that was a bug. That was a bug that was described, and that was fixed during, that was fixed on Friday. But yeah, there was a confusion. So even if me, who has been working on this topic for a while, got confused, I think it's a sign that this needs to be rationalized. So okay, so this is definitely wrong, but I suggest we are doing this, and I would like to do that. So I think Thomas had some opinions about this. Is this yeah, like, let them be heard.
By Thomas, you mean me, right?
Yes.
Yes. Okay. No. So actually, in Besu, from the test, it seems that we have the same. We look into the code to find where we might have reversed to little Indianness to follow the spec, and we didn't find it. So probably what you described is right, like meaning the mistake that we did with the Indianness. We also do not have the overflow check that you mentioned anywhere, so that's also a bug that we shared that you fixed, but we didn't on our side. And to us, like the fact that it's big Indian or little Indian is absolutely not an issue. It's probably better to have it big Indian, as you mentioned, because just for conformity with the rest. And in fact, we do pass it in when we pass it to UN 256. It's indeed assumed to be a big Indian representation. So big Indian seems good to us, anyways. So yeah, so we'll have to double check all this, but I think we do have the same bug, both bugs that you described, and we're ready to change this.
Cool. Yeah, please do that. Yeah, okay. So I don't know if anybody else has an opinion, but if not, I will be creating the PR to change that today, to change the spec today, and we can move on.
All right. Thanks, Guillaume, for presenting. Han, I think the person you wanted to join isn't there yet, unless I missed them. But yeah, the mic is
It's
yours.
fine. Yeah, it's fine. I mean, she just asked me for the link, but I guess she didn't see the message. But it's fine. Yeah, I'll present. So let me share screen. Right, cool. So, what I wanted to present is a new form of pricing that is, I guess you can think of it as something that's in between pre-pricing and state expiry. So using the concepts that we have learned from state expiry, but without the actual expiring part, so that we don't have to deal with the user experience. So this is an attempt to do that. So basically the general idea is to price state, but specifically state rights by the renewal age, which I'll explain later what is that. In essence, like older unmutated state would cost more to write. So that's basically the gist of how the proposal would work. As a reminder, majority of the state right now is can be expired, or it's very old and it's unused, inactive. So we would like to eliminate that as much as possible, or the general objective is to deal with the state growth issue that we have, right? So that's the goal that we have. So there's one point about mispricing is that, so imagine that you have Uniswap contract, which is fairly popular. So it will get access maybe every block or every few blocks. So when you do the state updates, or if you do state access in general, you would read it from the memory, most likely. But for older state, you will read it from the database. But in terms of pricing, for example, if you do an S store, the pricing will cost the same, but the actual resource usage is actually different because one reads from the memory, another one reads from the database. So when we do the gas cost, it actually, I mean, the real estate right cost varies between these two different states. And I think we can utilize this information to price it accordingly. So how it works in general is we would do an encoding change to, so this is on a MPT, we'll do an encoding change to the account and also to the storage slot. So we'll add an additional field, what I call as last written period to this to the account. But there will be no need to do a migration, because if you do if you activate the fork and a state, an account or storage slot hasn't been written to, or hasn't been written to, then by default it's going to be 0. So I just want to make that very clear that there will be no migrations needed. But we have to add this field, and you would modify the RP function for these two objects. So to illustrate it, so we have a global current period, which is derived from the current block number. So for example, if the current block number is 25 or 26 million, then depends on where we start the fork. You just minus it and then you divide it by how many blocks per period. So something like this. So let's say you deploy a contract, you write some storage slot. So by default, you start with 0, at least in this example. So this state right now is considered as active, but after a few period, or after a few years, for example, this slot becomes idle. So if you can see here, the last written period is 0. The current global period at this block number right now is 2. Period H is basically current period minus the last written period. So meaning that it hasn't been written to for 2 periods. So when you try to do an S store and a write operation, you have to pay an idle cost, or idle write cost, which is basically more expensive than active cost. So once you do that, you would you refresh the period, and then it becomes active again. So that's a I think pretty clear example. And then another thing is that there will also be dormant state, which is I'll show you the formula later, I guess. But basically this has been like very inactive, and dormant state will also have to pay like a dormant storage right cost, which is more expensive than idle storage right. So that's basically the gist of how it works. So basically what we are trying to do is to price it in different tiers, such that for example here it's just an example. We have active tier of state. Dormant is less expensive than a new stock creation. I think that's a very good question. Dormant state should be equal to the gas cost of dormant state right should be equal to, or yeah, should be at least equal to the new state creation. I'll explain later why we need to do that. But yeah. So here, for example, active state is like less than 1 year of inactivity. Idle is 1 to 2 years. Dormant is more than 3 years. It's just an example. Again, we can do like active is less than 6 months or less than 1 month or so on and so forth. But the thing is the right cost. The cost should reflect the tier. So active will be the cheapest, and then dormant will be the most expensive. So what updates the period? So again, here we are only dealing with writes. So if you do reads, it will not update the period. So because the initial proposal actually has I actually wanted to include reads, but we figured out that there are actually a lot of like problems with reads having to update their period metadata. So yeah, that's why I decided to only do writes, because the initial idea is to do hot cold storage separation, but because of the problems that reads bring, I think I switched the mental model to become like optimized for writes heavy or write hot working set versus like read only state set. So yeah. Yeah, so that's basically the gist of it. Reads do not change the period, and the gas cost of reads will also not be affected. Only the writes are affected. So in terms of the client level benefits, the most immediate and the most important one is storage tiering. So you can imagine that all of your active state is stored in memory. It depends on your spec, but hopefully at least most of it. And then for the idle state, you can store it in your fast storage or fast database or SSD here. And then dormant state, you can store it in a slower, compressed or optimized storage. So so it goes back to the question on why dormant state has to be the gas cost for dormant state. Dormant state has to be equal to new state creation. Is because if you so the plan is that we want to put all of the dormant leaves, and also the dormant trinodes into this separate storage, right? So that we can optimize it, we can compress it. But new state creation would there's a chance that new state creation would access some of the intermediate trinodes from the dormant state. So hence that's why the gas cost of new state creation should be as expensive or more expensive than dormant state. With the upcoming changes of in Glamseder, I think it's already getting a very, very, very expensive. So again, there are no actual values here, but we should revisit it. But that's just how I think of this dormant state gas cost versus gas cost of new state creation later. Yeah. Another idea on like this the benefit of this metadata is that you can do prefetching on restart. So you can imagine that if you restart the node, the clients can scan the database and check for state that is equal to the current period, and then you can rebuild the active set again. So that's also another benefit. Yeah. So yeah, that's basically the gist of how it works. So yeah, happy to take some questions or ideas. Yeah.
Cool. Thanks for presenting, Han. I have a few questions that come to mind or comments. First one that comes is you mentioned that there's no change to read operations at all. Why not?
Because you have like some corner cases where, for example, in static call, how it works is that you shouldn't modify existing state. It's only read only. But if you allow for read updating the period metadata, then it's kind of like a conflicting statement. So again, I haven't looked into detail whether this would be a problem for some contracts, or for client codes or whatever. But I think that's just one example of a corner case that we have to deal with. And another, I think, most immediate problem about reads updating the period metadata is that there are some state that is written once, and it's active in terms of reads. Like it gets a lot of S loads, but it has the value doesn't change. So essentially, if we do reads updating the period, and every time the period is updated due to the reads, we have to charge a write cost. So in some way, we are like penalizing.
You're turning reads into somewhat like some like half write operations or something like that.
Yes, exactly. So
well, could there be an intermediate? Also, like take away from what you said is like first we want like read pricing predictability and like consistency for smart contracts compatibility, and the second one is we don't want to have the burden of updating less like accessed time to do read operations. But like the second one, you could have it as like whenever something has been written during the last year, the read is less expensive. But you don't update the timestamp anytime you read. You just do with the last time it was written to.
But you also need to keep track of the read timestamp of a certain state, right?
Well, you could go with the last written period and use that as your freshness timestamp.
Okay. Yes. Yeah, but it's, I mean, again, it started off as like a push from state expiry, but if we were to go with this like only writes, then we can't really do expiry, because the definition of expiry is that we are eliminating state that has that's inactive in terms of access. So there are like in this example, if some state is read only, then the period wouldn't be updated. So, but we also shouldn't expire it. So yeah, so it's in some way, at least from how I see right now, it's not really compatible with expiry. But in terms of like storage tiering or storage separation, it helps. But yeah, it's a separate benefit, I guess, or trade-off.
Okay, cool. Yeah,
yeah, there's a bit of a like feasibility problem here, because I think, at least, but prove me wrong by all means, if you only want the last time it was written, like the problem, if you want to like be to detect that you're going to be the first one in the period to write a given location, you can't really do this, because supposedly when you start a new period, everything that is too old should already be deleted, potentially, could be. And if you don't know this, that means that indeed you need to go to the previous period and make every read, or technically you just need to make the last read of the period the period marker for that specific location. But you can't really you can't predict what is going to be the last period to write to. So that means that it should be the first read of every period of something that is already active. That should be the write. And yeah, okay, it feels a bit confusing. I could be wrong, or maybe I'm not making even sense, but I think it's really hard to do writes upon like to detect you're going to be the first person to read from the period and update it. And the only thing you could make it fair is if every read was actually a write, which is a possibility, but then that means massive increase in overall gas cost, and I don't think this is something we should go for. So in my view, I would prefer to have some mechanism where people manually keep some location active by using an out-of-band mechanism, like for example sending special transactions to say, hey, this is going to expire, but please reactivate its counter or something. It's not great UX, I don't like it, but I still think it's the simpler version. I'm happy to be wrong, and in fact I would love to be wrong, but I don't see how we can do it any other way.
Yeah, maybe I'm misunderstanding you. Like, are you suggesting that reads should also update the period metadata?
So what I'm suggesting is no, I'm not saying a read should, precisely not. I think we should not do that because it's not very easy for me. At least I don't understand how we could do it in an elegant or at least a practical and simple way.
Yes.
And so because of that, I think we should just add a new transaction type, yet another transaction type that would explicitly say, look, I am manually updating. I'm paying for it, obviously, but I'm paying for the update of this location's period. Otherwise, it's going to be more expensive or potentially expire.
Okay. Yeah. I think that's like the initial proposal that I had when I consider reads to update period. But here, reads don't update the period, so we don't really care about reads. But which is why I say, like, we don't think about, like, from an access point of view, but only from a write point of view. Because here, this proposal, this idea, we are only considering writes. So it's only writes will affect the period. So if there's a value that is read only, then the period will stay the same. For example, stay at period 0 forever. And how would clients utilize this information is that there will be, at least how I imagine that, is that the state set that is actively mutated, so all of the trinos and leaves, whatever, it will stay here. So to put it more concretely, for example, LSM3 database, because it's more optimized for writes. So then we move the read-only state set to a separate storage that, for example, B3 database, because it's more balanced in terms of like read operations. So rather than like a hot core storage separation, we have write heavy, write optimized storage versus read optimized storage. So yeah, I think that's a change that I made.
Cool, thanks. Some other things that came from me, and I think Lewis might echo some of this, is, if there are 3 discrete periods, like active, idle, and dormant, then necessarily there might be incentives to just keep an account into a particular active state, for example.
Yes.
So just the time right before the idle tricks up, like there's game theory there that maybe there could be a certain amount of like idle preventing transactions that are not, it's not really efficient because it's actually wasted transactions. But like if it costs 4 times more to do idle transaction, then there's a non-zero chance you're going to make transactions in the future that right to stake. You would be incentivized to keep it active or something like that, right?
Yeah, I think that there is incentive to keep it active. I think in the the original document, I also explicitly say that people would do this. I think it's normal. But like whether would people do it like, I mean, if you treat it as an incentive, yes, it is an incentive. But if you treat it as an attack vector, then it's not really an attack vector because I mean it depends on the parameters that we set for the periods. But if you set it at 1 year, then it wouldn't be an attack vector because it's impossible to touch all of the or write to every single account plus storage slot, and or at least it's going to be very expensive, and there's no point doing that. But incentive, yes, I do acknowledge that, and I think it's perfectly acceptable. To, for example, if you want to keep your account active, then you send a transaction every maybe right before the we go into the next period. I think that's
Yeah.
at least in my opinion, is acceptable.
Yeah. Have you thought about, like, let's say there are multiple transactions that want to write to the same state, and it's a dormant state. Like, people could set up transactions so that they like, people want to be second in line, right? Because they want someone else to pay up for the, like, reactivation costs. I mean, these might be more like general state expiry things, but yeah, I'm wondering about different game theory aspects of it.
Yeah, I think well, that works, but that there will be also another part of game theory where if you are the first and you pay the dormant cost, maybe the reward of being the first is more than you paying the active cost. So I think the economics will be quite complex here, but yeah, it's good to explore. But more stuff for MEV. Yes.
Yeah, exactly. Cool. The last thing on my list is, like, wondering about storage versus accounts. So, like, how does that? I'm wondering, like, if this is implemented and we have, like, the binary trees, like, suggested a redesign. How would the separation of account and storage, how would it interplay? Let's say I'm updating a smart contract that lives as an address, so I'm updating the account RLP, but I'm also, updating a few storage slots within it.
Yeah, I think for binary tree that would be different. I'm still exploring the options on, if let's say we go with this, then how would this mechanism work in binary tree? What I'm thinking right now is that because in binary tree we have the page-based mechanism. So here the metadata is per account and per storage slot. Then when we do it in binary tree, then we do it at a per page level. That's the simplest way that I can think of. In terms of transition, at least for now, I don't see a problem because when you are dealing with the page, for example, a page could have, for example, the account header page, you have a storage slot, some code, and storage slot, and then also account level. So you basically just take the highest period, and that would be the period for that page. So that's how I think of in terms of transition. But we could also not do page based. We could also do here like account based and storage slot based. But at least from how I see right now, I think page based is the simplest and make the most sense. But yeah, I think binary tree is still we still have to explore about it. Yeah.
Good. That's all for me. Guillaume has his hand raised.
Yes.
Yeah, so I actually have a few questions, but Luis and maybe Carlos asked some questions as well. So I want to give them the opportunity to speak first. My comment on the binary tree is that we should make sure it's forward compatible. But this is designed to come before that. So it's not going to be a big concern. We just need to make sure it's forward compatible.
Yep. Or Carlos, any questions?
I had one also in my comment there. So if I joined late, but are we planning to charge this period lookup, these counters lookups, because these are also extra work for the clients to be able
Yes.
to figure out what pricing they're going to apply.
Period. By what do you mean by period lookup? Like,
so how are we going to store these counters? They're probably going to the database, right? So we need to read them.
Yes, they are going to store it in database, but in terms of like the actual storage cost of adding this metadata is going to be very little. Based on the current state size that we have, is like 3.6 gigabytes. That's the worst case where every account and storage slot would have this data added. And yes, it's extra work, and with any EIPs, it's extra work. But the goal is to decouple the state growth, state size from, for example, state root calculation or the performance in general. Because how I imagine is that for the actively mutated set, it's going to be small, and because it's small, for example, in the LSM3 database, the size of the database would affect the performance a lot. So if you only use LSM3 DB for the active set, then and the active set is small, then it's going to help with the performance. And then for read-only state, you use some read-optimized database. So there's like a separation between these two. Of course, like now most clients are using a single type of database for storing everything, but the migration, I mean, the separation will need some work, and whether it makes sense for clients to do that work to achieve a better performance, I think that's I also have to ask you guys and for opinions. So yes.
Mm-hmm.
Maria, hello.
Hi, can you hear me all right?
Yes.
Yeah, okay. So random question here. So let's assume for a minute that we just go in this strategy where we make the current state really, really expensive instead of trying to like adapt it. We just create new types of state that are more tailored for state expiry and these like active, idle, dormant management. Would there be any gain in using this? So instead of trying to fit the current tree into a new design, just assuming like the current tree will become very, very expensive, and we'll just create new structures that fit more neatly with these state management, like active, idle, dormant. So would we have like any benefits from doing this instead of trying to adapt the tree we have, or not really? Does this make sense?
Yeah, I think I get what you're trying to say. In my point of view, I think most problem that we have regarding state is backward compatibility. Like if you do like if you create new state, for example, one thing that we have been talking about is temporary storage, which is a new form of state. Yes, it's going to help some contracts because some storage slots, for example, are just not meant to be stored forever, and they keep changing, and it can be stored in some form of temporary storage. But the problem is the adoption of it, because the contracts, that means older contracts have to migrate to this new storage, which is for some contracts, we can't assume that everyone can do that. So I think that's the biggest problem that we have, and hence I think yeah, I think that's the problem that we are trying to solve. Yes, Gil.
Yeah, to add to this, we still have the problem that the current state is huge, and even if you create new types and you get the adoption, you can still attack the tree by using the MPT. So unless we actually find a way to get data out of that, or that we completely, like we said, it completely read only, people are going to write to it, and there's a cliff that we know is coming, which is about not even double the size, a little bit under double the size. That's not going to be addressed by a different kind of storage. But the different kind of storage for sure is a great idea. We do have a proposal for this. But I don't think that's solving the problem that we need to solve, which is the MPT is currently really bad. Well, okay, it's not really bad, it's just bad, and at some point it's going to become a hindrance to performance.
Right. So I do see that point, but what I'm suggesting is that instead of having this tiering, like everything is just costs as much as a dormant access or a dormant right in the old state, and then you implement the cheaper one in a completely new structure. Like if you want to use the old stuff, you can just be super expensive. And yeah, if you want to store things cheaply, you just use the new structures. So what I'm saying is like we don't need to make active and idle cheaper in the current tree if we just give them a cheaper option in a better designed tree. But of course, this assumes that there's actually benefit in splitting the work like this, that is easier to implement than just changing the tree we have. But yeah, I'm just wondering.
Yeah, I think at least from how I see it is the incentive is more on contract developers. Like if you don't do anything and we keep everything expensive, then and then we have a new form of storage that is cheaper, then it means that we are telling everyone or telling the contracts to, hey, you should migrate this to this storage because it's more expensive, it's cheaper for your users. I think the incentive may work or it may not work because for some contracts it's just not possible to migrate. And yeah, so yeah, at least that's how I see it right now. So
Yeah, so but I think that's fair, but that's the same problem as we have here, right? Like if people, so in a world where everything costs as much as the dormant, you don't get worse than when you do tiering, right? In terms of state management. Sorry, what was the comment? I couldn't understand.
I asked why not? Why don't you get well, if you make every state right as expensive as dormant, well, first you got a huge UX problem. But let's assume.
But why? Why do you get the huge UX problem?
Because every legacy program is going to use the incumbent system, and right off the bat, from one day to the next, the costs are multiplied by I don't know how much, but like, if we make dormant very expensive, then all your costs are going to rise, and then excuse me, and then you need to migrate to a different system. But in this proposed approach, at least you have it's seamless integration. Whereas if you have a different type of storage, you're going to have to design a new system, and you're going to design a new interface, which all the legacy contracts will not understand. So USDC, USDT, all of that, they will become a lot more expensive. And I fail to see how this is going to be any different. Like you just have different tiers, except one of the tiers uses a completely different storage model, which is yet to be defined. Yeah, I don't really see how it's going to change anything really, except making things a lot more painful for anybody who has deployed contracts and using data as it is deployed today.
Yeah, got it. I think that's fair. So I think my main question was if there was a benefit there. It's like at the end, even like imagining you go through the hard period of all the contracts having to adapt. At the end of these hard periods, you would get to a better state management state because you were designing the idle and active storage in an ideal scenario where you don't have some design choices that you cannot take because you have to adapt to the current state. So because you have backward compatibility considerations. But if you feel like no, actually the end result would be fairly the same, then I think that answers my initial question.
All right. Thanks, Mario, for the question. Any other questions?
Yeah, I had a question. Just wanted to add one last thing. So I agree that if we can find a benefit, yeah, that would make sense. It's just that I'm not envisioning it, but we should spend time thinking in a bit more about that just in case. Yeah, it's just that I don't see, like, it doesn't come to mind right off the bat. Yeah, okay. My question was, and I'm sorry because my daughter barged into the room, so at some point, so maybe it's been asked at that moment, but if the I'm going to say cold, I forgot the name, dormant. If the dormant data is moved to an HDD, recovering it is going to take a lot more time because we say HDD, but it could also be an HDD on a different machine. Why not?
Yeah.
Is there, like, something that's missing for me from the picture for me is how long, if it takes 1 second to resurrect that data, is there some kind of asynchronous mechanism that I missed? Like, how do we, just the fact that we're going to pay more is not enough. We also have potentially, we have to provide the data fast, just as fast. But like in your model, it's moved to an HDD. It's not just your model, by the way, it's many state expiry models. How do we, justify this? How do we build something that is resilient to this kind of use case?
I think the criteria is still for dormant state access. The criteria is still that it should still be fast and it shouldn't take too long. It's just that active set, for example, active at idle should take it should be faster than dormant, hence that's why it's cheaper. But dormant state it will take longer and hence that's why it's more expensive. But it shouldn't be so expensive that you take up the whole like block time. I think at least that's how I see it. So if you want to do a more extreme version of like accessing from some archive storage, I think that requires some other mechanism which they're probably more complex. Like what you say, like async, like you try to access it, but you have to wait for a few blocks before you can actually get to fully access it. So I think that's another model.
Yeah, that's the thing. Because HDDs, I mean, I assume here no one has used an HDD in forever. Just to make sure this can still work, we would have to do some performance measurements, because if people do move this to an HDD, yeah, like it needs to work. It needs to be fast enough. We can't spend 1 second just resurrecting one node.
Yeah. Okay. Yes, Aragon. I mean, I haven't looked at what they did, but I guess it's kind of this. From what I understand, they are trying to use a mix of LSM and B3. So this would be, I guess, perfectly suitable for what they're trying to do, because one is optimizing for write, another one is optimizing for reads. So yeah. I think time is almost up. So I think if you have any questions, just ping. So I'll just pass it back to Gabriel first. Yeah. Thank you everyone for the questions.
Yeah, thanks, Sam. Thanks everyone for chiming in with the questions. Really nice when conversations get going like this. This is how we make progress. So yeah, as Han mentioned, you can contact him directly with questions if you have any. And yeah, we're about to end this call. So we'll be sharing a summary, the Stateless book, and a tweet probably coming out this week. So thanks everyone for joining, and we'll see you in 2 weeks.
Thank
Thanks.
you. Bye.
Bye.